Um, vertical motion. All right, so do you have that sheet that I gave you about?
I do.
It's annoying. T squared minus 4t plus 3. All right, so if you have that particle motion sheet I gave you, that would probably help you.
I remember if the velocity and acceleration are both the same sign, they're speeding up.
Yes.
If they're opposite, they're slowing down.
That's right.
I wrote it out.
How about, but it says describe the motion of the part. Let's first find the velocity and the acceleration. So derivative, right? So velocity here, because this is the position function, would be the derivative of the, right? So what is it? There you go. How about acceleration? The derivative of velocity, which is the second derivative of position, which is 2. Did it give us? Yeah, but good, do always do units. This is something per, well, I didn't give a shit. Something for something squared, yeah. All right. Oh, you don't look so upset. I know you are. That's why I said don't look like that. I'm really sorry. Yeah. All right. I have a constant acceleration, right?
That's implied.
I need some more coffee this morning. All right. So we found the velocity, we found the acceleration. Now we need to describe the motion of the particle. When does the particle change motion? And it says when t is greater than 0, but the sign of what switches? Velocity. When velocity changes signs. So to find out where velocity changes signs, I need to first find where velocity equals 0. So when does this equal 0? Well, if you add 4 and divide by 2, we find that at t equals 2, velocity is 0. It might mean that I change direction, or it might just mean that I'm stationary for a minute. Maybe I got tired and rested for just a second, right? So it said when t is greater than 0, so I do have an endpoint right here, and then 2, this is the velocity, which is going to tell us what the position function is doing. Are y'all okay there?
So
here, go ahead. What's your, okay. 1, if I plug in, 2 minus 4 is negative, right? Which tells me my position is moving to the left, right?
So when
it's negative is moving to the left. It's decreasing the position, right? Decreasing means I'm moving to the left. Y'all okay there? And then, how about past that? Positive, which means I'm moving to the right. So remember, just going back to refresh you, this was not asking the question, but to make sure that you remember. Where did I start? 0 seconds, but where did I start? At 3. Because if I plug in 0 seconds, I started at 3. So what happened was I started at 3, and then the first 2 seconds, I moved to the left. And then after that, I stop and I move to the right. Does that make sense?
So okay. When velocity changes size.
Correct. And that's okay. Do what helps you, for real, if that helps you. And goes right. But it doesn't start at 0. And this is a typical FRQ tested type question. And you have to remember to go back and find your position at 0. Don't assume that you started at 0. I didn't go from 0. Oops. Everybody good?
Wait, so Noah, you said something about this sign.
Yeah, so besides the velocity and acceleration are the same side. And then if they're opposite sides,
slope, if the slope is going down, right.
Describe the motion.
Yeah, yeah. How could I tell how much distance I traveled or where I was location-wise? I know where I started. I know I started at 3. How do I find the displacement? This is kind of going back and reviewing us a little bit since we'll be, so I'm sorry, but. Okay, so how are you going to do that? In other words, how do I start at 3? I know I start at 3. When I move left, where do I end up? What do I do? How many seconds did it take me to hit there? 2 seconds. So I need to find the position at 2 seconds. So S of 2, 2 squared minus 4 times 2 plus 3. 4 minus 8 would be -4 plus -1. So that means I started at 3, I moved all the way back to -1, right? And then if I wanted to see where I ended up, I'd need an ending time. If I wanted to know after 5 seconds or however many seconds I know I moved right. But just so you pull it all together, you realize what it is we're looking at. Y'all okay? Because at 2 seconds, that's where it changed direction. It stopped moving left and started moving right. So if I want to know how far, like it might ask you something like, how far past the origin did the particle move at 2 seconds? You just plug in the position function. It tells you where it is, right? But it didn't cover -1. How much time? Here's where your displacement comes in. How far did the bug travel altogether over that time? 4, right. He started at 3, and then he made it all the way down to -1. So he traveled 4. So if it asks you where they are, that's position. If they say how far did it travel, that's displacement. Distance, displacement, position is position function. Where? You okay? Anything else from your homework? Yeah. $38. Gross. But it's factored for you. You don't have to undo it.
Local extreme is the same as like the local maximum.
Yes. Yes. All right, so it says use the derivative of the function y equals f of x. So that's already given to us to find the points at which f has a local max, local min, and the point of inflection. The inflection points are what's going to get us here. Because the maxes and mins are going to be fairly easy to find, right? It's in factored form. So 1, 2, and 4. You're plugging into the derivative to see the sign. Remember when we set up our chart, this is the derivative, and it tells us what's going on with the function. So this would be 1, 2, and 4. This, by the way, is a repeated solution. Does it bounce or go through? It's even. Have y'all? It bounces. It bounces. Multiplicity is a repeated solution. It tells me how many times it crosses over, but it also tells me the nature of the function at the 0 there. So if it's an even, if it's repeated an even number of times, it bounces. So that vertex or that maximum sits on the x-axis. It doesn't actually change signs. And if it's an odd, then it goes straight through. So think about a parabola. Yeah. Repeated versus, actually, it could be something like that. That would be an odd number, an odd multiplicity. This would be an even multiplicity. Okay. At 0, I have -1. This is always going to be positive no matter what I plug in here. So I really just need to look at these two, right? So 0, that would give me negative and negative, which would be a positive, right? Y'all okay there? I chose 0. Because I'm looking at the sign of the derivative.
Oh, so what you could do is you could plug it into each of the solutions. I thought you just had to plug it in.
You do plug it in for all, but what I'm doing is, because this is multiplied and multiplied, I'm just worried about signs here because I want to know, is it positive or negative? The first one's always going to be positive. So I just need to look at the last two, really, right? A positive times anything is going to reflect the other sign. A positive times a positive is a positive. A positive times a negative is a negative. If you plug in anything after 4, what? Always positive for sure. Or if you plug in like 10, you get 2 positive numbers. Okay, how about here? 1.5. 1.5 minus 2 is a negative. 1.5 minus 4 is a negative, which is going to give me a positive again. Exactly. You're exactly right. There's my bouncing solution right there. Correct.
You have to multiply the, like for the first one, all we did was look at the sign of x minus 1 squared. But after that, we started looking. I'm a little confused. You have to plug in like if we're looking between 1 and 2, where do we plug that in?
I chose 1.5, all the x's. Yeah, all the x's. And what I was saying is, since that first one is x minus 1 squared, it's going to always, it doesn't matter what I plug in, it's going to be positive regardless. So it asked me for local maximum on this one, right? That would be at x equals 2. Local minimum, where is it? Does it have one? Or 4, that's right. It didn't ask me for absolutes, so I don't have to test any points. I don't have to plug it back in because it said local. If it had said absolute, I'd need to go back in and find out which one's bigger, which one's smaller, but it didn't ask me that. It just asked me for local, so I'm good to go there. And then part C is the hard part. It says points of inflection.
Second derivative sign change.
How am I going to find the second derivative of this bad boy?
A bunch of different
Some power and then some product. Okay, so look, this one's not gray. This is a calculator problem. The problem's going to be whenever you have to find the zeros. So you're going to be in a bunch of work either way you do it. If you try to do product and chain here, I was going to say, whenever I saw this, I went, holy crap, this is a lot of heavy lifting. But 38's a calculator problem.
So how would you?
Well, then that's fine finding the zeros with the calculator, so we should just.
So what I would do, now, here's the other thing you can think about. What if you used the first derivative to find the zeros of the second derivative? Can you do that? Can you think backwards there? Well, yeah, the maxes and the mins of this function would be the zeros of the second function, correct? Do you understand how I'm thinking through here? So instead of trying to find the second derivative, why don't I find where the derivative stops increasing and starts decreasing? where it changes
But that's
sign.
not gonna help.
Yeah.
That's
Sure it will. Okay, think about this for just a minute. Think about this with me for just a minute, okay? If I've got this function, okay? If this is f of x, right? What happens here? What's true about the derivative here? The derivative is 0 at these maxes or mins. Do we all agree? So if I look, remember, you told me I need the zeros of the second derivative, right? Isn't that what you told me? Well, to find the zeros of the first derivative, I can take the function and find the maxes and mins. Okay, but I can do that still. Just give me a second. But here, right? If I take this and graph it on my calculator, it is a quartic, right? It should be, it looks like a quartic with both ends going up. Is that right? Because it's... So if you were to graph this, does it come out looking something like that? Okay. If this is the derivative, how can I find where the second derivative is 0? And you could, Ren, use inderiv, the maxes and mins. This is where the derivative would be 0. Second derivative would be 0. Because this is the graph of the first derivative, right? Does that make sense? So either way you did it, you can go, Ren said he used inderiv on his calculator. That's fine also. If you go into y equals and you do inderiv, okay? Now, let me just set my camera up for just a second and show you. Because y'all struggle with inderiv for some reason.
I haven't used my calculator since
Just, send me an email about it. All right, here's what I'm going to do. I'm going to go into y equals. All right, I'm going to put the derivative in the first y equals because I can call that up if I need to. So I'm going to type x minus 1 squared x. I'm not going to put the derivative, I'm going to put the function. I mean, I'm going to put not the second derivative, but the first derivative, which was given. I'm not doing the derivative just yet. Let me just show you what I was talking about here. Okay, so I should have, see, I can't quite tell what's going on here. I could zoom in some, but I know here I should have a 0 for the second derivative, but we'll see. But what I could do is I could say y equals, go to the second y equals, and you can turn this one off if you want to. If you just hover over the equal sign and hit enter, it'll cut that one off, so it's not actually graphing it. Do y'all know how to do all this? No. Okay. Okay. When you're in y equals, you can type in the equation that you need to, like if I need to call that equation back up sometime to use it, and I'll show you how to call it back up. Yeah. I can type it in there, but I can hit the equal sign and I can unhighlight it so it's not graphing it. So if I want to graph some other things while I'm in there, I can graph them and look at them, and that's not impacting my graph. Okay. So I just went over and on the equal sign, hit enter. See how it's highlighted black now? If it's highlighted black, it's on. If it's not highlighted black, it's off. All right. Where's your calculator?
Oh, that is interesting. How do you call it back up? That's cool.
I'm going to show you.
Oh, it is.
Whoa.
All right, mine looks. I need a.
Wait, how?
Okay, wait. I don't want it to come up like
Back
this.
in the rib.
All right, listen. You're gonna do if you've got the 83. I need one of those.
Okay.
No. Hold on a second.
Nice. Look, I have it all set up for you. Oh my.
You can if you want to.
You know, I told Davis that he stole it and I was mad at him. I thought it was mine. All right, I'm gonna show you on both of these depending on which calculator you have. All right, if you have this calculator, I'm going into Riv, the X, and here is where I'm going to call up Y1, and I'm going to show you how to do it on the 83 in just a second.
We're gonna exercise it.
Do what? You've got one like this. I'm going to show you how to do it on the 83. All right, so now I need to call it up. So I am going to go. I have to remember where it is.
It's like copy and paste, but on a.
Test logic.
Oh, variables. Vars here over to Y vars, hit enter, and hit enter on Y1. And X equals X.
Bars and then Y.
Vars over to Y vars and hit enter on function. And you can call up any of those Y's functions that you've typed in. All right. Yep.
And then what do you do? X equals
I'm just going to show you the graph of it because, of course, we're looking for the zeros, right? I was going to say, please, Lord, work. Okay, so it looks like I've got 3 zeros there, which is what we thought. It was a quartic. We thought there were 3 maxes and 3 mixes. It just takes a while to calculate. Is that what you're talking about? Oh, no, it automatically is on. Remember, I'm typing in the second Y equals. I'm typing in Y2. Typing in Y. All right, if you've got an 83, Noah and Katie, and I can't remember, and Meg. All right, so I've got my Y equals in the first one, right? So what I'm going to do, I'm still going to do into Riv. Okay. Now I'm going to call my function up. So vars, sorry, y'all couldn't see that. Vars is right here beside clear. Vars over to Y vars function Y1. And then X, and that should graph it for me. It's the one I prefer. I do. It takes a while.
Yeah, this one
It's like actually. If she said E equals X, this one's graphs are fully exponential.
Is your graph, is it on? Are you highlighted beside Y2? Okay. Now, with all that said, If you need to find the derivative at a specific value, sometimes it is easier. Whenever I taught you in deriv, I think most of the time we just typed the derivative in the main screen. So if we were here and we went into in deriv, let me show you on both of them. And then you would just type the function in here. You can still type it in y equals and call it up from there. And sometimes it's easier that way because you don't get mixed up in all your parentheses and everything else. So you can type the function anywhere you want to, and it'll call it up for you.
Wait, what do you mean it'll call it up for you? You can't type it up.
So if I want to know what is the value of the derivative, okay, because remember, I'm finding the zeros, and then I want to know, well, is it positive or is it negative? So maybe I come here and I say, okay, find the derivative of y1 when x equals 5. It's positive. And so if you've got multiple values to find, it's easier than retyping it in each time. Correct.
No, that was first derivative.
Well, I graphed that's the second. Oh, yes, that was the first. No. Right, so I could call up y2. If I want to know the sign of the second derivative.
That was the second derivative. The equation gave us the first derivative.
But I put y1 in here, so I called up the second.
Oh my God.
Y1 is the first derivative, y2 is the second. I'm testing points of inflection. I'm looking for concavity now. Because I told it, find the derivative of the first equation.
Okay.
So now, if I want to know the value of the second derivative, I can go math and deriv, right? And now I'll call up y variables. I'm going to call up y2 this time in terms of x at what value? Whatever value you want it to be. Let's say -5. Let's go past that 0 that way. Positive. So that means it's concave up. That was second derivative. Okay. All right. Let's take a little break in between, and then we'll start. Just a fancy word. That means finding what? What? Which is exactly what we have been doing already. If you optimize a function, if you find an optimal value, it's the maximum or the minimum. If you're optimizing profit, you want the most profit you can have. If you're minimizing cost, we have done this. So, yeah. So here's our strategy, because we're going to be working in terms of like word problems. In general, both. The calculus of it we've really already done. And that's exactly what we're going to do. Okay, so the first thing we're going to do is we're going to get the function in terms of just one variable. And then, of course, we do what we've already done before. We derive set equal to 0, test the intervals, find the da-da-da-da-da, right? Everything we've done before. And we find the extrema. Now, here's the problem. We may have multiple equations that we have to solve one equation for a variable and then plug that into equation number 2. Again, it's gonna be the algebra that throws you off on things like that, and not the calculus as much. He's eating the donut stick. The donut stick is being eaten at the moment, and the yoo-hoo. That's the kind of stuff we have when we go camping. Junk food.
That's the type of stuff I have every day.
You what?
I have this every day because I'm unhealthy.
It's crazy though.
It's just because, like, I have really good metabolism.
Enjoy it.
Like,
All good things must come to an end. They'll catch up.
yeah. I'm just gonna enjoy it while I
Who is Taylor name? Who was she name? Who is she?
And we please do optimization team.
How?
I've got examples too, not example one.
It's number 2 from your homework, but it's an example.
Okay, well, if you also want to marry a college bankrupt boy, rate of change.
This is straight from, you don't have to copy it down if you don't want to. I just wrote it down to reference. What is the largest area for a right triangle with a hypotenuse 5 centimeters long, and what are the dimensions? That is a thing, but not necessarily. You'd have to know that one of the other sides was. All right, so let's think about what we know. We've got 2 different things going on here. We've got area, and we've got this right triangle with hypotenuse 5. So I'm going to draw a picture because that always helps me. Everybody agree?
So why did you circle area and right triangle?
Okay, because area is what I'm trying to optimize, okay? I know that I'm trying to optimize that because it says, what's the largest? That clues me in right now, a max. That's exactly right. Now, I'm going to use calculus for this, although I really technically probably wouldn't have to, but I'm going to use calculus for this for the sake of example. All right, so I have this right triangle whose hypotenuse is 5. Now, remember I told you get a function in terms of just one variable. Okay, so let's think about that for just a second. Just one variable. I don't want more than one. So let's name this, instead of the normal A and B that we would normally call this, let's think in terms of area. How do you find the area of a triangle first? Where's the base and where's the height?
The base is that one.
So you're exactly right. I'm going because remember the key here is just one variable. So can I write B in terms of H or H in terms of B? How? You're exactly right. Okay. My key, and that's going to be the key on all of these, and it's going to be the hardest key of all of them, because this just needs one other variable. So what I'm going to do is I'm going to say, okay, well, I know by Pythagorean theorem, you're absolutely right, that h squared plus b squared equals 5 squared. Yeah. Do you all agree with that? So then do you also agree that h squared is 25 minus b squared? So h is the square root of. Agree or disagree? Well, I'm going to keep all of this for h. Remember what I'm optimizing. I'm optimizing area. So what I'm going to do is I'm going to plug this in for the h, because I don't want to derive with more than one variable. I only want one variable when I take the derivative. So a equals 1/2 base. Now here I plug it in. Square root of 25 minus b squared. Now it's a problem we've done before. Because you can't split them up when you're adding or subtracting under the radical, only when you're multiplying or dividing. Well, if I were doing this problem, I would probably not simplify it any, but I would move straight into deriving it. So I'm finding the derivative with respect to what variable? So I'm finding dA dB. You could have done this with h. It doesn't matter because at the end of the day, I'm going to go back and plug in and find what these dimensions actually are. Okay, I'm going to find the largest possible area and I'm going to find those dimensions. Yeah, absolutely. That's exactly what I would do. So product rule here. Derivative of the, it could come out to be that, but we don't know. We want to know the one that gives me the optimal area. Which one has the largest area? It actually does not come out to be 35. All right, so 1/2 derivative of the first times the second plus the first times derivative of the second. So 1/2 25 minus b squared to the negative 1/2. Chain rule. So this was derivative of the first times the second, derivative of the first times the second, plus the first times derivative of the second. What would be to the 1/2? 25 minus b, it would be to the negative 1. Oh, yeah, sorry. Right. Yep, I'll give you a second to catch up with me. Dude, I was just trying to help. Everybody was saying where did it come from. That's derivative of the first times the second plus the first times derivative of the second. All right, are you all with me? I do all that chain rule stuff. Thank you, Ben. All right, I'm going to end up with a fraction here. I've got 1/2. I'm going to go ahead and put this back in a radical so you can see exactly what's happening. Plus, actually, nope, minus, because of the negative. The 1/2 and the 1 are gone. I mean, the 1/2 and the 2 are gone. That was in here when I moved into the room, and I don't want to take it down. What? Okay. Look at what I did here. What? Now remember, I want to find the zeros of this because I am optimizing area, yes? Yep. This b times this b gives me b squared. Now, whenever I end up with fractions like this, it is hard algebra. It is. You're exactly right. Get it into a single fraction because remember, I need undefined points as well as where it equals 0. So to get this into just one fraction, now notice the calculus that I've done here has not been that much, right? But this algebra is just killer. That's what gets you. All right.
And so you put that in the denominator because you have that negative 1/2.
Correct. All right, I've got two fractions that I am going to consolidate to one, but oops, before I do,
Wait, no, why wouldn't it 25?
that's why I said oops. Okay, I am going to get this into just one fraction, so I'm going to give it what it needs, okay? That's exactly right. I'm going to give it. That's exactly right, which is going to help me, believe it or not. 25 minus b squared minus b squared all over. Remember, the whole point was so that I could get just one fraction, so that I could combine the numerators. Keep moving along. I've got 25 minus 2b squared over 2 times the square root of 25 minus b squared. Dear Lord.
Dear God.
Remember, don't get lost at what you're trying to accomplish, right?
I don't even know.
What are we trying to accomplish?
Largest area.
Largest area of the triangle. So I found this is the derivative of the area. So now I have to set it equal to 0 because that's the point, right? I could see this definitely being a full-on FRQ.
So, yeah, but don't you have a one of them thingies in the denominator?
One of what thingies?
Like a restriction or
Well, I do, but I've got an undefined point up top. Yes. All right, so here we go. When I need to do the top equal to 0, that will tell me where, and this is a calculator problem, by the way. So theoretically, you could have done what we did before on the derivative, but even on a calculator problem, they need you to show the derivative and show. Okay, here we go. 25 minus 2b squared equals 0. That will tell me where the top is 0, yes?
So 25 divided by 2 is?
I would do 5 over root 2 equals b.
I didn't know you could do that.
How'd you know you could do that?
You can't have a negative length of a triangle, so it's just going to be the positive.
Just move the radical to the bottom.
Oh yeah, wait, don't we have to rationalize the denominator?
Okay, so, well, no, not on here. Don't worry about that now. Now remember, I need to check for undefined points because those are potential critical points as well.
Undefined point
Where this equals 0, but yes, if I solve this for 0, I'd have b equals 5. But if I go back to my triangle, it can't be 5. Why?
because
The hypotenuse is 5. So that solution makes 0 sense, so I eliminate it. Okay, but I still need to check. So the point that I am checking is 5 over the square root of 2, and I am just going between 0 and 5. It can't be any bigger than 5 because my hypotenuse is 5, right? You wouldn't have no undefined points. No undefined points. Oh, you're talking about if I solved it and got 3, then I would have another point here that I would be checking. All right. Test them. See what you get.
It's just missing me. This my problem is there's no way that on the test that we will not make a single mistake through this entire process.
That's right. And that's also why, yes. And if you get part A wrong on the exam, it's not dependent on part B. You know what I'm saying? Don't ever just, if you can't do part A, you don't go to part B.
What about derivative? That's not anything.
I give you partial credit. Oops. No, you're plugging into the derivative. The sign of the derivative tells you what the original is doing. So therefore, well, this is a calculator problem, so I would have used my calculator to do this for me, to see if, okay, so what I would do on this, Meg, is I would put this into y equals, right? And then, oh, you said the store x? Okay, if I want to store x, if you take out your calculator, if I want to check maybe 1, hit 1, and then there's that little arrow button. and then you'd hit the X. So 1 stores X. 1 in the main screen. Yep, just hit 1. This is if I want to test 1, and then hit the button above on that says store, or it says that little arrow, stove, and then hit X and hit enter. And now you can type your equation, 25 minus 2x squared divided by all of this. You'd need parentheses, of course, and hit enter. Second enter. If you hit second enter, it'll call up the last thing you typed, and then if you hit second enter again, it'll do the next to the last thing. And you can keep doing that to keep calling up until you get back to where you want. That's a huge time saver, actually. Most students don't realize you can do. Okay. I have not yet answered the question because it asked me, what's the largest possible area for a right triangle whose hypotenuse, and what are its dimensions? So to find the largest possible area, I know that happens when B is 5 over the square root of 2. Do you agree? Do I? Maximum. So to find the maximum area, I've got back to my area equation all the way up here, and I'm going to use this one because it's in terms of the base, right? So I do 1/2 times 5 over the square root of 2 times the square root of 25 minus 5 over square root of 2 squared. If you were an FRQ, you were A-okay to leave it just like that. I went back to the area that I wrote just in terms. Or what you could do is go back to the height, because you have to find the dimensions anyway, right? I know the base. The base is 5 over root 2. I could say, well, that means the height is 25 minus 5 over root 2 squared. What? I'm going. 50 over 2 minus 25 over 2 would give me 25 over 2. Ironically enough, if you look, this is a hypotenuse. This is an isosceles right triangle. So both sides are 5 over square root of 2. It is a 45, 45, 90. Which is a special right triangle, which I'll say. Area, so you can do it one of two ways. You can, okay, so the dimensions are 5 over root 2, 5 over root 2, right? This, I know, I just found this. It comes out to be 5 over the square root of 2. I've still got this 5 over root 2 and this 1/2. I'm sorry. There's my area. Comes out as you are used to as a nice, not so nasty value as opposed to what. The maximum area is 25 over 4, and the triangle has dimensions of 5 over root 2, 5 over root 2 by 5. This would not have a minimum on this unless you went in, well, you wouldn't, right.
This is the type of problem where you're taking the test and then halfway through you just start. Like you just start tearing up. It's like, I hate this class. It's not Mr. McGee's.
We also only had like 15 minutes at the end.
It's not Mr. McGee's fault they made it so hard.
It's supposed to be 1 through 12. Let's go.
1 through 8. 1 through 8. 1 through 9.
What's it? What was the area?
I